A chip leaving a Lingang packaging line carries no extreme ultraviolet fingerprint anywhere in its supply chain, and it outperforms what the embargo was supposed to cap. The accepted rule was straightforward: compute density scales by shrinking transistors. Shrinking requires extreme ultraviolet lithography, and extreme ultraviolet lithography is the one machine the West controls. That rule still holds for individual transistors. It is breaking apart for systems. Before you read this as spin, the pivot to stacking is not a face-saving retreat. It is a deliberate engineering reorientation with a specific economic and strategic logic. Advanced packaging determines memory bandwidth, chip-to-chip latency, and artificial intelligence compute throughput. Whoever sets the packaging standard sets the performance ceiling for the next generation of artificial intelligence hardware. Not just phones, but the servers that train the models running everything else. By the end, you will understand why the stacking pivot is rational rather than desperate, what Lingang is actually building, and why the embargo's leverage is weaker than it looks. This is not really a story about one manufacturing technique. It is about which direction of progress stays open when one door is bolted shut, and who builds the staircase. So what exactly does extreme ultraviolet lithography gate? And what does it not gate? Think of a city trying to add population. One way, shrink each apartment, pack more units onto the same floor plan. The other, build taller buildings on the same land. The zoning law, the embargo, bans new ultra-compact floor plans. It says nothing about building height. Extreme ultraviolet lithography is required for sub-7 nanometer class planar nodes, the kind that TSMC and Samsung use at the leading edge. Older deep ultraviolet tools are sufficient for mature nodes, and China has those. Memory bandwidth, crucially, scales with stacking height and interconnect density, not transistor node. High bandwidth memory achieves its performance advantage by stacking dynamic RAM dies vertically, connected by channels drilled straight through the silicon called through-silicon vias. That architecture is publicly documented by SK Hynix, Micron, and Samsung. The embargo is real and consequential, but it is a gate on one dimension of chip performance, not all dimensions. Smaller transistors still win on power efficiency and raw clock speed. For memory bandwidth and multi-die compute throughput, stacking is the dominant lever. Those are not the same race. So if stacking is a real path, why is China the one making it a primary lane? The rest of the industry, TSMC, SK Hynix, treats advanced packaging as a complement to node shrink, a second engine bolted alongside the main one. TSMC's CoWoS packaging is in such high demand for NVIDIA artificial intelligence accelerators that packaging capacity has become a genuine bottleneck. SK Hynix leads high-bandwidth memory Generation 3E production. The global industry knows stacking matters. What is different in China is the prioritization. Denied the shrink lane, China is making packaging the primary vector, which means it is building packaging depth and domestic tooling at a pace and priority level no one else is matching, because no one else is forced to. Changxin Memory Technologies is reportedly developing high-bandwidth memory class products. That is a company claim and reported signal, not a confirmed volume production, at high-bandwidth memory, 3 specification or above. But the direction is clear. Chiplet interconnect standards are largely open, and China is participating in them. The question is not whether stacking works. The whole industry agrees it does. The question is who builds the deepest infrastructure around it. Which brings us to Lingang. Lingang is a special economic zone in Shanghai, and it has been reported as a hub for advanced semiconductor packaging investment, high-bandwidth memory-style stacking, chiplet integration, and co-packaged optics capacity being built across multiple firms and state-backed ventures. Confirmed company names and output volumes are not in the public record, at the level of detail that would let you call this confirmed mass production. What is confirmed is the investment priority and the strategic intent. The piece worth pausing on is co-packaged optics. Think of it like moving the electrical substation inside the building instead of a block away. You lose less energy in transit. In data center terms, integrating optical transceivers directly into the chip package, rather than running signals across a board, reduces the power cost of moving data at hyperscale artificial intelligence inference volumes. And at that scale, the savings are worth billions of dollars in operating cost. Co-packaged optics at Lingang is reported as in development, not confirmed shipping. The investment is real. The production status is not fully resolved. Here is what makes this more than an infrastructure story. The tools required for advanced packaging are not on the same embargo list as extreme ultraviolet lithography. ASML in the Netherlands makes every extreme ultraviolet machine in the world, and those machines are export-controlled under a coordinated United States, Dutch, and Japanese regime. Advanced packaging requires a different toolkit: deep ultraviolet lithography, wafer bonding equipment, through silicon via etching tools, substrate fabrication. The Netherlands tightened deep ultraviolet controls in 2023, but the restriction is less absolute than the extreme ultraviolet ban. Wafer bonding equipment, the machinery that fuses stacked dies together with precision down to microns, has key suppliers including BE Semiconductor in the Netherlands and SET in France, but also a growing field of domestic Chinese entrants. Confirmed Chinese domestic market share figures for bonding equipment are not in the public record, so that claim stays directional. What is clear is that the packaging toolkit is more widely sourced globally, harder to single-source embargo than a machine only one company on Earth builds. The window for extending controls to packaging equipment may narrow, and there are reported signals in Western policy circles that exactly this is being considered. That window has not closed. Now, the honest limitation, because it is real, a stacked system of mature node dies consumes more power per unit of compute than a leading node monolithic chip. That is an established engineering fact, not a rhetorical caveat. NVIDIA's H100, which China cannot legally import, uses both TSMC's leading node and CoWoS packaging. Its performance comes from both layers simultaneously. China's stacking efforts can approach the bandwidth layer. The node layer remains constrained. For training frontier models at maximum efficiency, that gap costs something real. There is no confirmed independent benchmark of any specific Chinese stacked product against H100 class systems, so no parity claim belongs here. What the evidence supports is this: for inference workloads, for memory bandwidth-bound tasks, and for artificial intelligence applications running at the edge and in data centers at scale, the stacking path gets you far enough to be consequential. Second best is not the same as irrelevant. Zoom out, and the larger pattern becomes visible. The embargo's leverage was designed for a world where transistor shrink was the only staircase to higher performance. Stacking is a second staircase. And each generation of packaging improvement, as a reasoned inference from high-bandwidth memory's generational bandwidth progression, reduces the unique leverage of the extreme ultraviolet choke point for the workloads where stacking is already competitive. The people who designed the embargo understood this risk. The reported debate within Western policy circles over whether to extend controls to advanced packaging equipment is itself evidence that stacking is being taken seriously as a route around the restriction. Stacking buys time. If it delivers sufficient performance for the dominant artificial intelligence workloads of the next several years, the node gap's strategic consequence is deferred, possibly long enough for domestic lithography development to close part of it. Time is the variable the embargo was designed to consume. Stacking is buying it. Here is my honest read. The triumphalist version China has already routed around the embargo through packaging overstates what is confirmed and understates the real power efficiency cost of the node gap. The dismissive version, stacking is a consolation prize that changes nothing, misses that artificial intelligence inference at scale, is bandwidth bound, not node bound, and that China is building the toolchain to own that lane with more focus than anyone else, because it has no other choice. The honest read, the embargo locked one door and inadvertently clarified which door was worth walking through. The staircase is real. The climb is incomplete. The door to the other staircase is not yet bolted. The real question was never why China stopped shrinking. It was always which direction of progress stays open when one door is bolted shut, and who builds the staircase. So here's what I want your honest read on. Does the stacking lane buy China enough time for its domestic lithography to catch up? Or does the node gap compound faster than packaging can compensate? Both are defensible. Tell me which way you read it and why in the comments. Subscribe if you want to follow the packaging equipment embargo when it comes. That is the next move, and you will want the context already in place. That chip with no extreme ultraviolet fingerprint already left the building. The question is how high the staircase goes.